You can refer to that and you can take down the notes. For now, you just focus on understanding the chapter, right? Okay. So, what is an atom?
The smallest particle.
Exactly. So, let's suppose we have matter, right? What is matter? Matter is anything in the world, anything in our surroundings, anything in our surroundings which has mass and occupies space, which has mass and occupies space. All right. So let's suppose what is which has mass. Let's suppose we have air. Let's suppose we have a table. So table, you know the table has mass. And when table has mass, and if you place a table, it is definitely going to occupy some space. If you keep a ball, so this ball will do what? This ball will do what?
Occupies.
Exactly. So this ball shall do what? This ball shall be capable of doing what? Occupying a space on the table. So ball, fan, all humans, isn't it? All humans. What are humans? Humans occupy space, isn't it? So
Yes.
if you are sitting, so you're occupying certain space. If this person is sitting somewhere, you understand? If this person is sitting somewhere, so this person is occupying a certain space, a certain volume. Hence we say that it is an atom. Hence we say it is a matter. Do you understand my point?
Yes.
Any doubts in this? Just tell me. Now it says what is an atom? Now understand. Let us suppose we have this particular bar and I cut it into half. And I have this half of the bar. All right? I have half of the bar. Then again I cut it into half. Again I have half of the bar. Again I cut it into half of the bar. Again I have half the bar. So what am I trying to do? I am saying that you keep on doing what? You keep on dividing the bar into half and half and half and half. And you will reach a point where it will be the smallest atom. And you cannot divide the smallest atom. Are you understanding?
Yes.
So you had a bar A, you divide it into half. So you get bar B and B, two B bars. You have a bar B, you divide it into two C halves. You have a bar C, you again divide it into two D halves. And you keep dividing it into half and half. I hope you're understanding. When you keep
Yes.
dividing it into half and half, you will get a particular part, which is what? You tell me. You will get a particular
An,
part, which is what? Tell me.
an
Which
atom.
atom, which cannot be further
Divided.
correct, which cannot be further divided. You understand? So this is an atom. Are you understanding my point?
Yes.
So this is the concept. Any doubts in this? Right? So basically, there was a scientist called as John Dalton. He gave he gave the Dalton's theory of atom. He gave the Dalton's theory of atom. Now, what was this Dalton's theory of atom? You understand? This Dalton's
Yes.
theory of atom basically said, this Dalton's theory of atom basically said that that atoms are indivisible. The very first point of the Dalton's theory was that atoms are indivisible. That atoms are indivisible. That means you cannot further divide an atom. Atom is so small. Okay? So atom is so small that you cannot further divide an atom. Then he said all the atoms, all the atoms of a particular substance, all the atoms of a particular substance are similar. Okay? In terms of in terms of shape and size and mass. Shape and size and mass. What does that mean? You must have heard of certain substances in nature. Like suppose you must have heard of hydrogen. Have you heard of hydrogen?
Yes.
Have you heard of chlorine?
Yes.
Have you heard of sodium?
Yes.
What are these? These are basically the substances. These are basically the substances whose atoms, if you see, so the scientists wanted to say that, if for example we have hydrogen in nature, if we have hydrogen in nature, what is going to happen? Just tell me. If we have hydrogen in nature, so all the atoms in nature of hydrogen are exactly the same. In terms of what? They're all spherical, you can see. They're all circular, spherical. Are you understanding? They are of the
Yes.
same size. They are of the same size. You understand?
Yes.
They are of the same size. Third, what is there? That their mass is also same. So for if this is 1 U in mass, this is also 1 U in mass. What is U? U is atomic mass unit. Atomic mass unit. Just the way we have kgs, just the way we have AMUs. You understand?
Yes.
On the similar lines, what do you think we have? 1 U, 1 U, 1 U, 1 U, and so on. Do you understand my point?
Yes.
So this is the concept. So it says that he gave the Dalton's theory of atom, and the first point was that the atoms are indivisible. The first part. Second part is that all the atoms. Let's suppose we are talking about hydrogen. All the hydrogen in the universe. According to Dalton, he said all the atoms are spherical. All the atoms are spherical, and all the atoms are basically, similar in terms of shape, their size means their radius, and their mass is also exactly the same. Understood or not?
Understood.
Right? Okay, the third point that he gave was that the atoms of different substances are different. The atoms of different substances are different. Are you understanding?
Yes.
So atoms of different substances are different means what? The atoms of different substances are different. What does that mean? You tell me. What does that mean?
That they're not the same.
Exactly. Let's suppose we are talking about hydrogen. All the hydrogen in the universe and all the sodium in the universe. Wherever you will find out the atom of hydrogen, hydrogen's atom is small, sodium's atom is bigger. That means that, if the mass of hydrogen atom is 1 U, the mass of sodium atom is 23 U. The radius of hydrogen atom would be less, okay, and the radius of sodium atom should be more. So basically he wanted to say that the atoms of different substances are different in terms of what? In terms of mass and size. In terms of mass and size. You understand my point? The atoms of different substances are different in terms of mass and size. Are you understanding?
Yes.
So, what exactly I'm trying to tell you? The atoms of different substances are different in terms of mass and size. That means what? You tell me. That means what? So, there is hydrogen and there is sodium, but what is same in both of them? Same is the shape. Same is the shape. Are you understanding my point?
Yes.
Both of their shapes is spherical.
This.
Any doubts in this? All right. So, this is the concept. Any doubts in this? All right. So, the third part. The fourth part that Dalton said was the fourth part that Dalton said two elements combine with each other. Two elements combines with each other in a fixed ratio by mass. Now, what does that mean? You understand? To form a compound. Now, what does this mean? You understand? When we are talking about the Dalton, okay? When we are talking about Dalton, what does it mean? You see, understand? It means that when we're talking about Dalton, so he said that we have H2 and we have O2, isn't it? So H2 is an element, O2 is also an element. I hope you're understanding. But when they combine, they form water. H2O is the formula of water. When I say water, okay? When I say water, that means what? Water basically does what? You tell me. Tell me. Water has two atoms of hydrogen and one atom of oxygen, right? Water has two atoms of hydrogen and one atom of oxygen. Are you understanding my point?
Yes.
So when water has two atoms of hydrogen and one atom of oxygen, so that means if I tell you this one thing, hydrogen is what? The mass of one hydrogen atom is 1 U and the mass of one oxygen atom is what? The mass of one oxygen atom is what? Is 16 U. So what is the ratio when I say H2O? What exactly does that mean? You tell me. Mass of one
Uh,
hydrogen atom is 1. So what is the mass of two hydrogen atoms? 2 times 1. So
two.
plus 2 because mass of one hydrogen atom is 1. So the mass of two hydrogen atoms should be 2. And the mass of one oxygen atom is going to be 16. So hydrogen is to oxygen. The ratio shall be 2 is to 16, which is going to be 1 is to 8. Am I right? So the ratio is going to be 1 is to 8. Are you understanding my point?
Yes.
All right. What is that concept basically? The concept here it is that when we are talking about H2O, it means that the ratio of hydrogen is to oxygen shall always be 1 is to 8. Which means what? It means that no matter what kind of water we are talking about, it could be rainwater, it could be rainwater, it could be tap water, it could be ice, it could be anywhere in the world, any type of water. Water on any planet, the formula shall always remain H2O. Are you understanding?
Yes.
The formula shall always remain H2O. Understood or not? And secondly what? When we are talking about H2O, And the ratio of hydrogen is to oxygen's mass shall remain 1 is to 8. For example, H2O. I hope you're understanding H2O. So the mass of one hydrogen atom is 1U. So the mass of one oxygen atom is 16U. So what shall be the ratio? H is to O. The ratio shall be 1U is to 16U. Because in the water molecule, we have two atoms of hydrogen. So 1 times 2. So the mass shall become 2U is to 16U, isn't it? So it is
Yes.
going to be 1 is to 8. Are you understanding my point?
Yes.
So when I have 1 is to 8, what exactly does that mean? You tell me. It is going to be 1 is to 8. And this ratio shall remain 1 is to 8. Are you understanding? This ratio shall remain 1 is to 8. I hope you're understanding the concept. So my point is, no matter where we talk about CO2, so mass of one carbon is 12U and mass of one oxygen is 16U. So when the mass of one carbon is 12U and the mass of one oxygen is 16U, so carbon is 12U is to 16 times 2. So that is 32 is to 12. Are you understanding?
Yes.
So what is the simplest ratio? 2 times 6, 2 times 16, 2 times 3, 2 times 8. So 3 is to 8. So no matter where in the universe you collect CO2, what is CO2? Carbon dioxide. So carbon dioxide produced by burning anything. Carbon dioxide produced by burning anything. Carbon dioxide, produced from plants or absorbed by plants. Carbon dioxide produced by humans. Anything, anywhere, wherever the carbon dioxide is coming from. You understand?
Yes.
Anywhere in the world carbon dioxide is coming from, what is happening? The ratio of carbon's mass is to oxygen's mass shall always remain 3 is to 8. Are you understanding my point?
Yes.
Any doubts in this? All right. So this is what we understand by the Dalton's theory. So what were the points of the Dalton's theory? The points of the Dalton's theory were that atoms are indivisible. All the atoms of a particular substance are similar in terms of shape and size and mass. All right. All the atoms of a particular substance are similar in terms of shape and size and mass. Okay. Are all exactly same. What is the Dalton's theory of atom? Next, what do we have? Next, we have the third point that the atoms of different substances are totally different. The atoms of different substances are totally different in terms of mass and size. Are you understanding? The atoms of different substances are different in terms of mass and size. Then what do we have? We have the last important postulate. The most important postulate is this one, that whenever the two elements combine, they always combine in a fixed ratio by mass. Whenever the two elements combine with each other in a fixed ratio by mass to form a compound. Are you understanding my point? So, two elements combine with each other in a fixed ratio by mass to form a compound. Are you understanding my point?
Yes.
So, that is a concept. Any doubts in this?
No.
All right, that is a concept. So, I hope you're understanding that this was the basic theory that the scientists gave us to explain what an atom is and what was their observation of an atom. They also told us that two atoms combine, they form. So when two atoms combine, they form a molecule. Whenever two atoms combine, like suppose if I say O2, So 2 written here at the bottom indicates that there are two atoms combined together. Do you understand my point?
Yes.
O2 means what? O2 means two atoms combined together. When I say P4, that means four atoms of phosphorus combined together and combined in such a way that they cannot be separated very easily. If I write 4p, you know, if I write 4p, what does that mean? You tell me. If I write 4p, what does that mean? That four phosphorus atoms are there. Four phosphorus atoms are there, but they are separate. But they are separate. Are you understanding my point?
Yes.
That is the concept. So, what is the difference between P4 and 4p? You tell me. What is the difference between P4 and 4p? You tell me. P4 means four atoms of phosphorus combined together. 4p means four atoms of phosphorus which are different. Are you understanding my point?
Yes.
That is the difference. Any doubts in this, just tell me. When we talk about O2 and when we talk about 2O, what is the difference? Tell me. O2
Uh,
basically means two atoms of oxygen combined together. 2O means two oxygen atoms but separately. Separate, not combined, no attraction between them. That is the difference between 2O and O2. I hope you are understanding. So SA means a molecule of sulfur. And you have to remember this, a molecule of sulfur. A molecule of sulfur. And here 8S means what? 8 atoms of sulfur. So basically, 8 atoms of sulfur. 8 atoms of sulfur combined 8 atoms of sulfur separate. So here molecule of sulfur formed by joining 8 atoms of sulfur. Yes or no? That is the concept. That is acid. Any doubts in this? All right. Now, so I hope you're understanding what is a molecule. When I say CO2, CO2 is a molecule of carbon dioxide. Molecule of carbon dioxide means that, ma'am, it has one atom of carbon and two atoms of oxygen combined together. Molecules of carbon dioxide. That it has one atom of carbon and two atoms of oxygen. When I say H2O, this is a molecule of water. This is a molecule of water. When I say O2, this is a molecule of oxygen. This is a molecule of oxygen. When I say C6H12O6, this is a molecule of glucose. Glucose, you know. When I say C12H22O11, this is a molecule of sucrose, or you can understand sucrose is nothing but sugar that we use. Sugar. So these are all the molecules. What are molecules? Group of atoms combined together. Group of atoms combined together. Do you understand my point? This is called a group of atoms. Now, how do you understand? It has 12 atoms of carbon. 12 atoms of carbon. It has 22 atoms of hydrogen. And it has 11 atoms of oxygen. Are you understanding?
Yes.
It has, now see, look at the molecule of glucose. It has 6 atoms of carbon. It has 6 atoms of carbon. Yes or no? It has
Yes.
12 atoms of hydrogen. It has 6 atoms of oxygen. Yes or no? So
Yes.
basically, every molecule is made up of atoms. Every molecule is made up of atoms. I hope you're understanding my point. Yes or no?
Yes.
H2O. What is that? Every
What?
molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. Are you understanding?
Yes.
So these are all the molecules. There is a gas called as ammonia gas. Ammonia. Are you understanding?
Yes.
So what is my point here is that all of these are molecules. Molecules are what? Groups of atoms. Now you see what am I talking about? I am talking about atoms, right? Now atoms join to form molecule. Atoms join to form molecules. Yes or no? And when atoms
Yes.
join to form molecules, what do you think is happening? When atoms join to form molecules, so molecules are of two types now. There are simple molecules and there are complex molecules. There are simple molecules and there are complex molecules. Are you understanding?
Yes.
So, when we are talking about the simple molecules and the complex molecules, what do you think it means? Understand. When we're talking about the simple molecules and the complex molecules, what do you think it means? Simple molecule means, understand. Simple molecule means those molecules, those molecules made up of only one type of atom. Simple molecules are those made up of only one type of atom. And complex molecules are those which are made up of which are made up of more than one type of atom. More than one type of atom. Are you understanding?
Yes.
When we are talking about the complex molecules, what are complex molecules? Complex molecules are those which are made up of more than one type of atom. Do you understand my point?
Yes.
Understood or not? And simple molecules are those which are made up of only one type of atom. Like, for example, if I say O2, N2, H2, P4, S8, O3. O2 is oxygen atom, oxygen molecule. Why? Because I can see a 2 here, but both the atoms of 2 here means 2 atoms of oxygen. 2 here means 2 atoms of nitrogen. 2 here means 2 atoms of hydrogen. 4 here means 4 atoms of phosphorus. 8 here means 8 atoms of sulfur. 3 here means 3 atoms of oxygen. Are you understanding?
Yes.
That means what? That means what? That we have 3 oxygen atoms, 8 sulfur atoms, 4 phosphorus atoms, 2 hydrogen atoms, 2 nitrogen atoms, and 2 oxygen atoms. And all the atoms in a molecule are of the same type. Are you understanding my point?
Yes.
Any doubt? That means what? That means what? When we are talking about the atoms, they join to form the molecule. It means those atoms made up of only one type of atom. Those molecules are called as simple molecules. So these are all the examples of simple molecule. Do you understand? These are all the examples of simple molecule. Any doubts in this? Yes or no?
No.
Tell me. All right. Molecule. And any molecule, let's suppose H2O, CO2, HNO3, H3PO4. All these molecules are what? You tell me. All these molecules are nothing but what? Tell me.
Complex
H2O,
molecule.
CO2, HNO3, H3PO4. What are these?
Complex
These are
molecules.
complex molecules because they are made up of different types of atoms. H2O, when we say H2O, so it is made up of one atom of H and two atoms of H and one atom of oxygen, one atom of carbon and two atoms of oxygen. HNO3 is made up of what? One atom of hydrogen, one atom of nitrogen and three atoms of oxygen. Are you understanding my point?
Yes.
So that is the concept. So when we are talking about one atom of hydrogen, one atom of nitrogen, and three atoms of oxygen, they are called different atoms. They join to form a molecule, and this is called complex molecule. Are you understanding my point?
Yes.
Okay, that is the concept. That is the concept. So this is about the atoms. There is a term called as atomicity. Atomicity basically means what? Atomicity basically means the number of atoms in a molecule. So, atomicity of a molecule means what? Means the number of atoms, the number of atoms in a molecule. For example, if I say O2, so this O2 molecule has two atoms. So, I will say the atomicity is 2. I say O3, this is ozone, this is oxygen. So it has 3 atoms. So the atomicity is 3. P4. So this phosphorus molecule has 4 atoms. So the atomicity is 4. Do you understand?
Yes.
We have H2SO4. So, two atoms of hydrogen, one of sulfur, four of oxygen. That means what? That means what, you tell me? So, we have two atoms of hydrogen, one atom of sulfur. So, 2 plus 1, 3. 3 plus 4, 7. So, basically, this entire complex molecule has two atoms of hydrogen plus one atom of sulfur plus four atoms of oxygen. So in total, how many atoms does it have? 2 plus 1, 3 plus 1, 3 plus 1, 3 plus 4, 7. So the atomicity is 7. Are you understanding? So the atomicity of H2SO4 is 7. Understood or not?
Understood.
Okay, this is the concept. So when we are talking about the atomicity, I hope you're understanding. When we are talking about the atomicity, what exactly does that mean? The number of molecules, the number of atoms in a molecule is called as the atomicity. Now, there are certain substances which we say what? There are certain substances for which we say that, helium. Let's suppose we write helium, neon, argon, krypton, xenon, radon, sodium, magnesium, you know, lithium, beryllium, boron, carbon, etc., etc. All of these. We do not write down any number right here. Here, we do not write down any number. So there is no molecule for them. So I will call their atomicity is 1. Do you understand? Their atomicity is 1. Any doubts in this? When I say O2, H2, N2, F2, Cl2, Br2, I2, their atomicity is 2. So we call it as diatomic. We call it as diatomic. Understood or not?
Understood.
O3, CO2, H2O. These are all triatomic. P4 is called tetra. Tetra means 4. Atomic. Atomic means the atomicity is 4. So when I say P4, that means the atomicity is P4. It is a tetraatomic molecule. Do you understand my point?
Yes.
Any doubts in this? Just tell me. So we have O3, we have CO2, we have H2O, and so on. Understood? And similarly, we will have pentatomic, hexatomic, or heptatomic. Heptatomic, just I gave you the example, H2SO4, sulfuric acid. H2SO4 is called sulfuric acid. Alright. Heptatomic molecule. Understood or not?
Yes.
So that is the concept. Alright. One second. Do you understand the atomicity? So atomicity means the number of atoms in a molecule. So helium, this is He is helium, Ne is neon, Ar is argon, Kr is krypton, Xe is xenon, Rn is radon, Na is sodium, Mg is magnesium, Li is lithium, Be is beryllium, B is boron, C is carbon, and so many elements. Are you understanding the basic concept? Just tell me.
Yes.
So this is how it basically works. So when we're talking about helium, neon, argon, krypton, xenon, radon, sodium, all of these elements have atomicity, and these are all simple molecules. H2, O2, N2, F2, Cl2, Br2, I2 are all simple molecules. Why? Because they have two atoms, and these two atoms are basically made up of what? Same type of atoms.